Yeah, we have Sven Ruppert with us. We have Gertjan together with us, and we are gonna talk about Foojay, which is a new online community around OpenJDK. Gertjan will speak more about this. JavaBin is the Norwegian JUG. We have 8 regions around the country, and we do these monthly online meetups. We have a crew that's helping us to keep this alive. I'm very happy for everyone who is helping us keeping our meetups alive. If anyone has any questions about javaBin, please contact us. That was basically my introduction. I will now hand over the word to our speakers. And I just want to say thank you so much, Gertjan and Sven, for being with us to share your insights and information with our community. So, Gertjan, I will hand the word over to you.
Thank you very much. Let me start by sharing my screen. So you should see right now Foojay. Hello, my name is Geert-Jan. I'm in Amsterdam in the Netherlands, and I work at Azul. I work on open source projects there. And before Azul, I worked in Oracle on open source projects. And before that, I worked for Sun Microsystems on open source projects. So really my entire experience in the Java ecosystem has been to work on open source projects. I worked on, especially on NetBeans, and I still do. It's now Apache NetBeans. I worked on Oracle Jet, which is a free toolkit for front-end development by Oracle, and open source as well. And what I'm currently working on since a year is Foojay. And Foojay is what you see right now on the screen, Foojay.io. Foojay stands for Friends of OpenJDK. And if you are a Java developer, you're using the OpenJDK in some way to create applications, or if you're learning Java, you are by definition a friend of OpenJDK. And what kinds of things do friends of OpenJDK need? You know, what do you need as a Java developer? What kind of information do you need? What has happened over the past years, of course, is that there isn't only one Java vendor anymore. When I was in Sun Microsystems, Sun was the Java vendor, and every few years there would be a new Java release. What's happened in the meantime, of course, is that there are multiple different Java vendors. So providing different distributions of the OpenJDK. If you want to use Java today, there isn't automatically a place that you would go to find the Java. Java is provided by Amazon, it's provided by Red Hat, it's provided by Azul, it's provided by Oracle, it's provided by Belsoft. So here you have on Foojay an almanac listing the different OpenJDK distributions. Now, something else that has happened over the past years, in addition to there being multiple different vendors for Java, is that there have been multiple different releases. Now, when I was in Sun, there would be a new release every couple of years. Now, there are quarterly updates to major releases. And there's a new major release on a much more frequent basis than before, on a very regular cadence. And also 4 times a year, there are updates to those major releases. So let's say that, that we're using Java 8. Here are all the issues that have been fixed for Java 8 in the recent quarterly update. So we're now in April, and every April there is a new update to Java 8 and to Java 11 and to the other releases of Java. And so here you can see what's actually been fixed. So you may be aware that there is a quarterly update, and you assume that there are fixes, and you assume that it's more performant, but do you know what is actually in there? So on Foojay, you have a complete list. So even from here, you can jump into those issues, but even this is not all that useful because it's still a very long list. So you can look at the component view which shows you those issues broken down into the different areas. So maybe you're interested in Hotspot. So this is what's been fixed for April 2021 in Java 8. So now you can start browsing through these, and you might find a couple of topics that you find interesting, like G1, for example, and you know, there are various topics here that could be relevant to you. And if you find them relevant, then you will click on here on the stars. Now, you don't have to log in to do this. This is just to say, hey, this is interesting. I like this. This is a good fix. You know, you can read each of these items and decide, well, this is relevant for me. And all the ones that are voted on will automatically appear on the highlights page. So the highlights page presents a view. So let's go to April 2020. So you can see here that for April 2020, we can see the most voted on fixes. And you can also see a commentary. So for example, here there is a fix that is quite popular for April 2020 for Java 8. The fix is entitled Integrate Marlin Renderer per JEP 265. Now that's really unclear. What does it mean? So we at Foojay have added an annotation because this is a fix that the community likes. So we have an annotation, or we have analyzed this, and we have added here a commentary. JDK 9 switched to using the higher performing Marlin renderer. This is a backport of that feature to JDK 8. Well, that's useful information. So what we want to do with Foojay, as you can see in these two examples, is bring together all the different fragmented reference materials that there are in the Java ecosystem into one place. Another example of this is JVM command line switches. Where do you go to find what all the JVM command line switches are? There isn't one single point of reference. And there is actually, because a very nice Java champion called Chris Newland has a site called Chris Who Codes, and you have to know that it's there in order to be here, of course. And here he has all the JVM options listed. Now what we have done is we have integrated that content into Foojay. So on Foojay, you get his content, just like the Almanac is an integration of content by Mark Hoffman. So there are various Java champions and other people in the Java community who have information on their own separate platforms. And with Foojay, we have the opportunity to integrate that information into one place. So these are the three key pieces that Foojay provides at this point, but also there is an area called Foojay Today. Now this is for blogs. So every day we publish a new article, and here are the authors who publish on Foojay. And there are many well-known people that you will have heard about in the Java community, like, for example, Gerrit Grunwald, who is a JavaFX expert. You might have heard of Eva Grimstad from the Eclipse Foundation, Jakarta EE, Jaden Altlip from Payara. Many people, Raid Sang is on here, Matt Rabel, you know, many people who you might know from the Java community, but also people that you might never have heard of. So we want to also enable people who are new to the Java community to present their insights and their work and their tutorials and their content. So it's really a WordPress site. So if you have a blog yourself, you can republish your existing content on Foojay, or you can write new content on Foojay. There's a lot of new content and also republished content on Foojay. Now, one interesting area is game development. Now, you might not know, but there's a wonderful game engine called FXGL, which is on top of JavaFX. And the creator of that is a very nice guy called Almas. He was a lecturer at the University of Brighton in England, and he uses Foojay to educate people about the game engine. So he has fantastic tutorials that he's building and publishing on Foojay. Every week in the next few weeks, you'll find a new tutorial about game development, creating simple games by means of his JavaFX-based engine. Another example is release notes. So every Java technology has release notes, but imagine if we were to collect all the release notes of all the Java technologies into one place, into Foojay, so that you would read about Payara's new release, but also about WebLogic's new release, and also about Sneak's new release, and you know, all the new releases, that we would have all that information collected into one place. So these are the opportunities that we have in bringing together content into Foojay. So what Foojay also provides is a front page where you find all the content, like an events calendar. Are you organizing a conference? Are you organizing JUG events? Why not publish your events on Foojay? So here is the event calendar. It's going to be much better. I mean, everything is in progress, but here is the starting point of it. So here you see the upcoming events, and you can also add into your calendar, etc. You can go from here to the event page. You can do a search across the events for common terms. We can go much further. I would like the idea of having hotel recommendations, for example, on Foojay, so that if you've been to GeekCon before, for example, that you would, or to Java Day Istanbul, and you've been to a nice hotel, that we would list that on this page, that we would get people to recommend particular hotels, or to say, well, if you are in Copenhagen, these are the nice places to go to, that Java developers share their insights about the place where the conference is. So there's a lot of interesting things we can do together. There's something called the Foojaypedia. So this is like Wikipedia. These are definitions of different terms, like TCK. Do you know what the TCK is and why it is important? So all these terms are defined here in a lot of detail, and you can add new content into this too. And there's a tweet area. So if you write a nice tweet about Foojay, then we'll add you to the greatest tweets. So really, it's a community collaboration site for anything related specifically to Java. To wrap up a little bit, who is behind Foojay? So it is a group of different organizations who are very well known in the Java community. I mean, everyone knows about Sneak and Payara and JFrog and Hazelcast and DataStax, Datadog and Azul. So these are the organizations behind this project. And there are people that you've heard about, like Stephen Chin, for example, Simon Maple from Sneak. I like this quote from him. It's incredibly important for every ecosystem to have a core location for information to help grow the community and be an educational resource for all developers to use. Java has lacked this core space for many years. So this is, we want to fill that space. We have a Slack channel, of course, and on the Slack channel, every Monday morning, we do our scheduling. So we want to publish one article per day, per week, every week. And every Monday morning, we look in the WordPress and we see what is in draft and we schedule together. And it's all done very simply and collaboratively. The final point is that we have, of course, a Twitter stream, Twitter handle, Foojay.io. Please follow Foojay.io. Within a year, we have 2,000 followers, which isn't a bad thing at all. And we want to grow this, and we want to grow the community, and we want to be of service and of use to the Java community. So please follow along on Twitter, join the Slack channel. I'll put those links into the chat. And that's Foojay. So what we're doing now is we are actually on a tour to promote Foojay, because it's all quite new. It's existed for about a year now. And this is the final stop of the tour. We spent the last month or two going to as many jugs as possible. We went to about 10 jugs in March and April. This is the final stop of the tour. And Sven Ruppert is one of the people involved in Foojay, and especially JFrog is on the Foojay board. And so as one of the community members of Foojay, Sven is speaking now. I've known Sven a really long time. You can see his background is a forest. If you look on YouTube, you find lots of YouTube clips about him walking in the forest and talking about Java tips and insights. He's worked at Vaden. He's now working in JFrog. He has a long history in the Java community. He's a great speaker with deep knowledge. And so with that introduction, let's switch over to Sven.
Hello, hello. So we heard about Foojay and the place. Everything is about Java, and then we want to follow up with Java again. So here we are talking about functional reactive with core Java. So, well, now the trickiest part for me, I will start sharing my screen. Let's see if I'm able to do this one. And here we are. So you should see my screens now, my screen. So let's start. So my name is Sven. I'm working for JFrog. JFrog is the company behind Artifactory, X-Ray, and Pipeline, some other stuff, but the most people will know Artifactory. And if you need some binary manager, then have a look there. And we have a free tier. So check it out. So, by the way, if you want to reach me, Twitter, LinkedIn, YouTube, everything, but please no mail, because mail is just, I don't know. Try something else, please. By the way, if you are attending today, I'm not sure if you see it later on YouTube, maybe it's too late, but if you're right now online, you can use this URL I'm providing here, javaBin.co and javaBin, and you will find slides and a video link. And if you're fast enough, you can win one of the shirts. I think 10 shirts we have, and they will be selected during the next, what's ending here? 3 days. So feel free, if you want to have one of the shirts, grab one as soon as possible. So back to the topic. What we are talking today, we are talking about functional reactive with core Java, and the target here is to have functional approaches without adding other big libraries or different typing systems and whatever. The other thing is that I was mostly working in projects with a lot of legacy code and with a huge code base. And it was not so easy just to change the whole typing system or to add a bunch of libraries because I just want to do it. So I was mostly focusing on the core JDK. And then there was this idea of, hey, functional is cool, but we have an object-oriented language with Java. So can you combine it? How you can combine it? And what are the basic principles? So what I'm not doing here is giving a pure theoretical exercise that you will get from university. I will just focus here on practical approaches. And the first thing I want to have as a starter is what is the difference between OO and functional programming? This is mostly the first question I'm hearing. So where's the border? If you're coding functional with Java, where's the border? Can I see it? And if you're looking at the screen, I just took the optional. You have different ways to deal with this. You have this option is a holder. This is great if you want to avoid null. So this is one of the things you don't want to do in the functional, with functional approaches. You don't want to say, here's a null. You always want to give something back, some result. And then optional is one of the solutions. So it's a holder, inside there's a value, maybe not, you can ask something. And if you're now looking at this API, is what of this is functional now? Is a usage of optional functional? Is it functional because you're using lambda expressions? Is this functional because you're using message references? Is this functional because you can add transformations and then working again on some optionals? To say the truth, I think there is no clear border. And the aspects or the stuff I want to explain about the functional aspects or the functional behavior, what you can do with Java is not pure functional, but you can adopt a lot of these things. And then it will be up to you if you're reaching or at what level you are reaching your functional approach or your level of functional programming at this or with this language. Just as a short recap, I want to let's say the functional interfaces. Functional interfaces, the name says functional. Is this functional per definition? Well, not in the term we want to have it, but functional interfaces are quite interesting because we need later some places for the API to put stuff like who's responsible for creating instance of a function, what is the right place to write down the code for a generic function. So what is a good place? And interfaces are quite a good place for this because functions, per definition, are stateless. So a function means one input value, one output value, and there's no state, and interfaces are not bad. The other thing is you can go with interface over composition instead of inheritance if you are mixing different functions or different behaviors you want to compose. And this is the next thing with this functional world. If you're going more to the functional world, you're leaving the track of the pure inheritance or pure object-oriented way. So we need some places where we can put our source code, where we can guarantee where it's convenient, and interfaces are not bad. There are a few things with interfaces. For example, functional interfaces, just as a recap, just if you have one method signature that has no default implementation, then if you have this marker function interface, yes or no, we don't need it. And we got this default implementations with JDK 8. It's a long, long time ago. And what we see here is that it's always, it's still a functional interface because we have just one method that we have to implement, one method signature. So that's it. The next thing is I want to play a little bit around with inheritance and functional interfaces, because with this default implementations, what we got is who's the winning implementation. And this is just as a short exercise, because if you start designing APIs and you're using then this functional interface or this interface in general, then it's much good to think about what you will see from outside, how to deal with inheritance or implementation details if you have different methods and so on. So what I want to do here is I have this interface A, and this has two methods. One is a static one with a default, or with an implementation. There's no default implementation, it's an implementation. And then a method do something with a default implementation. By the way, this is no functional interface anymore because there is no method signature without any implementation. So we have this default implementation here, and we have the static one. We have the interface B, and it's now extending interface A, and we have the same method signature to something, and again with the default implementation. The question who's winning if you're using this one inside inheritance. And then there's this tiny piece. I have an interface C, exactly the same method signature and with the default implementation. Why I'm saying this one is you have with this, if you're going to the functional world, functional or being functional is pushing abstraction to the limit. Pushing abstraction to the limit means at the same time that you are using more and more generic atomic operations of functions. More and more generic operations and functions means that you're using more generic words. And I saw it quite often that different parts of the company or even inside the team, they use the same wording, and it was leading to the same method signature. And this could collide somehow if you start dealing with method references, with this functional approach if you have composition over inheritance. But here, so what I've done is just I created these three interfaces, and if I'm implementing A and B, what's the winning one, and what is winning if I'm implementing A and C. So here the compiler will immediately say there is no strategy to solve it, so you have to do it. The compiler will break and the method do something. You have to implement the other one. If you're using this one, then you will see that interface B is a winning one for class A. But a few people are thinking about how to deal with static methods. So we are using static methods later for providing stuff to have access somehow, or use static imports to make this syntactical nice. But if you're implementing interfaces and you want to call the static methods, you can't do it over the implementing class. So you can't call class A.do more. You really have to say interface A.do more. Why I'm mentioning this one, if you're creating an API and if you have all this sorted out, what you want to implement in what's the right place, make sure that not too many details are bleeding to the outside, so that people need to know so much about your hierarchy inside your framework or library. So just have this in mind. That will be necessary if you have it. Okay, so if you're calling this and you have this diagram, what we will get is interface B is to something and interface A is just the latest concrete implementation will winning, the winning one. So JDK 9 gave us private methods. Here we can just clean up a little bit the code from default implementations. It's a long time available, these private methods, but I see so much code with huge default implementations, they're not taking advantage of it. So just maybe it's a good time to think about this private ones again. So back to the functional thing. the first approach, or what you read in if you're reading about functional approaches in core Java, is that you should use optional. Optional is okay, it's nice. So you have this folder, you can ask it if it's empty. You can create an optional. You can create an optional with a null inside, with so that you have nothing. That's all fine. You have methods like is present, but you don't have a method like is absent. So you can get the value, you can build a stream since JDK 9. So this is okay, but you have a few things I don't like. So for example, here with this optional, what we have is this is present or else, and then you can decide if you want to go left or right. That's okay. You can do it with if present, but you can't do it with if absent. So this is not existing. Then you can use, for example, this or else throw. It really depends on the JDK. It's evolving over the time. But for example, or else throw, is this functional? I would say no, because one of the functional approaches is catch all functions, but don't throw them. Given result, don't throw exceptions. This means that this or else throw, from my point of view, so being a functional thing, would be not right in this API. But on the other side, we have to use it object-oriented. We have to use it functional in the same way. So this is maybe, so this is a thing that's there for the object-oriented. But throwing exceptions is something I wouldn't do. If we're talking about how to map stuff, what we can use lambda expressions, we can use method references. Method references have some tricky things in terms of type safety, but what we can do is we can now start transforming. So we have this value, we start working on this value without grabbing it out. And this is one of the good things. So you have the value, then you can say, okay, transform. And this is more or less the first approach of thinking about adding transformations and working with some stuff. Okay, what we have to think is how to get rid of this wrapping. So we have this flat methods, and here I'm just highlighting this or else and throw. Well, I gave my comment on this one. So, but what we have is this optional for me is not symmetric enough. So as I mentioned before, we have if present, but we don't have if absent. We have just locking calls if we want to move later to functional reactive, so to the reactive world, because functional reactive matching perfectly, then we have just blocking calls. This, okay, for me, it's not functional enough. So I'm missing a few things. For example, the information about what was going wrong if there is a null value, and it's declared final. So we can't extend it. So we have to deal with this. If you want to have something like this, then do something else. What we can do is, as an approach, is we are taking just optional and all method signatures, creating a class result of t, and then one thing is what we need is it must be easy to transfer between optional and result to optional from optional, because otherwise your colleagues maybe don't like this, or it's just ugly wrapping code. It should work like a drop-in replacement. So take all methods from the optional and then extend what you need. And then you can, with search and replace, just make a drop-in replacement. And this is easier than just changing huge amount of code with different semantics and all this stuff. Should be connecting to the reactive world. I will show what I have in mind, and it must be symmetric. And this is one thing that I really want to see in the optional someday, if that for every negative method you have a positive one and reverse, so that you don't have this inverting stuff. So if not, then do something. So it's not nice. But have in mind, if you're creating some functional stuff, make it usable for the OO style world, because you have to deal with colleagues, and maybe it's a bigger project. You can't just switch the whole style. So this is one thing what I had in mind during the whole stuff I created here, so that it must be usable in the OO world clearly and good. Otherwise, the acceptance is not so good. So To transfer is just to optional, from optional is just a wrapping method. And now we have the first thing, and look at this method signature. So result success is something, okay, I have a value and I can type it here. I have a string and then I have a result of type string. If I have maybe a none, a result with no value in, but I want to have some informations, and this is the first extension to the option. For example, the error message or some whatever informations, I don't want to lose the type. So even if I have a result of failure with a text input, it is still a result of the original type. This, for example, here integer. So make sure that this typing is very, very clear so that you're not mixing up this one. But this is the first thing. So just hold additional information if something is going wrong with a result that is responsible for the failures. So the next thing is if absent of present, it's exactly what I spoke before. It's just to make sure that you have for everything the positive and the negative way. With if present or else, we got with JDK 9 or 10, something like this. So this is already there. But I want to have this failure message, for example, as input for the negative way. So this is something that I would provide so that you can consume or use this information. But this is only available if you're storing it before. So that's one thing. Okay, if you have this one and we want later to connect to the reactive world, make sure that you have for every method signature something like if present or else asynchronously, so that you have a clear wording, clear API, so that you can switch to the reactive world and make sure that the naming is very straightforward here at this point. By the way, all this source code is available on GitHub. I can share this link here in the chat or in the comments on YouTube later. So you don't have to type anything. It's available, so you can play around, and it's Apache license, so you can use it easily. So the only one thing that is interesting if you start thinking about functional world is you're thinking about transformations. So you must be able to combine things and to provide transformations. So this is a little bit like the complete Foojay API. So then combine asynchronously. But why this is only in the complete future world, you can do it with an optional or with a result in this term here as well. So just provide an additional value and then the transformation. Because otherwise you have this code that you're grabbing stuff out, feeding it to the next one, and then wrapping it back to an optional. So this is not enough. So we have this maps, this pure transformation, a value there, and it will be transferred. Or you have something like a combination so that you can merge paths with transformations. Okay, there's one thing. Then the same stuff asynchronously if you want. So it's just, we will come do this later with this reactive style. Because what I'm doing here is straightforward. I'm just consuming computable futures, and the return type is then something that's able to deal with asynchronous calls, and there is a complete future. And so we have the full typing and the possibility to deal with complete futures. So, okay, combining functions. One thing is that I want to highlight is that most people are just thinking about values, and then a function, but an instance of a function could be a value as well. So it is in a way that you can see a value a little bit broader, not just an int and string. A value could be a function as well. We will come to this. Okay, one thing in the function word is don't throw exceptions, but we have exceptions in Java. So mostly I found this code, so that's try catch, so everybody knows it. And it's even worse if we have the stream, so we have a bunch of values, and then in this map phase, oh no, I have then an exception. So what I see mostly is that inside this map phase, they have something like try catch, and we have two challenges here. The try itself is very repetitive. It's not nice. I want to extract it. The next one is a return type here. For building a sum, it's okay, but if you have something else, you don't have it anymore, a value that you can use as a default answer if something is going wrong. So a solution could be that you start wrapping it in optional. So it's the first thing, okay, don't push null, so wrap it in optional, and then you start with filter if present, or just do it by a stream or whatever. But this is not nice. So this is a huge amount of boilerplate code that's just not nice. So what can we do? Yeah, this flat map is just new syntax with JDK known that you don't have this if present and filter stuff. So what you can do is you can just extract this try catch. This try catch is a pattern, and this pattern is just try to invoke something. If it is going wrong, then catch this message and wrap it in a holder. So what we have is a checked function. We have on one side just this apply with exception thing. So this is a method I want to implement. So our functional interface is the message method signature that I want to implement, so I can throw exceptions. So I have no challenge anymore. And then I need this try catch and wrapping in some holder in a way that I can extract it. And this is quite easily done because I just have this checked function. I have these two types, and the return type is a wrapped type. So this is something I have to do. Otherwise, I'm not getting rid of this null. But if I have this one, I can just use this checked functions with lambda expressions. And what I have with this already. So if I have here's the implementation of the check function. It's really just apply implemented. And then this apply with exceptions is the add-on. And then you can use it exactly in the way you know. So if I have a checked function, I have already a check consumer, because the consumer is nothing else as a function from T to void. And I haven't checked executor with this one as well, because this is a function from void to result of void, because I need the result if something is going wrong, but I have void in, void out. So I have a checked executor with this. I have a checked supplier, because the supplier is just something that can give me a wrap type and with null inside. So even here, I have exactly the same. So with this approach, I have a lot of stuff already in a way that I don't have to write this boilerplate code. And this is going into the functional world, because we are catching all exceptions, throwing no exceptions anymore. The next thing is, what's the function? Function is a transformation input-output, and we are talking mostly about one input value, one output value. So the question is, what can we do? So I see quite often constructions like this. You have a function +2, a function +10, function +5. And if you want to go to the functional world, what you could do is, or what you should do, you don't write down what you need, describe what you need. So the function approach is describe how to get it instead of writing down what you need. And here, what I need is definitely something that will give me a function that is possible to add a constant. So how to create it, how to do it. Mostly, people are thinking, okay, a function is just value in, value out, but a value could be a function itself. So if you're doing this one, then you have to think about, here I want to start combining. So you have to think about how to create a function that is able to create my final function. I will come to this in a few minutes again. So with JDK 8, if you want to combine functions, here it's, for example, a compose. We have compose and then. If I'm going over compose, I have some challenges because I need to add a lot of syntactical stuff, because the type interferencer needs information. There's something happening before my invocation, and I will get something out of it. And then I have my input type, and I'm creating some output type. So this is with compose something that's not nice. So the traditional way, so adding functions in this order leads to a lot of syntactical stuff, because you can't write this gray style. So this x +5, x +10, you always have to add this type information. If you want to get rid of this one, you can do a lot of stuff. For example, you can write in higher compose. I definitely say don't use this in production. It's just play around with the type interference, and this will lead you to this construction. It's just a nightmare. And what you will get is exactly the same. You have a description what you need. You have a function that is able to build from an input function, a function that is able to create from an input function an output function. Okay, this is by far too complex to use it. The only target here is for this high compose. Would it be possible to extract this type information in a way that you don't need to declare it, or a different way to declare it to make it shorter? And the result is not good, because what you have is you have all this typing information for every single step during the invocation of the method. So the type interferencer really needs this information be given, and you can't extract it on the fly. So there is no generic way of doing this one. So, and you have a very long syntax. So this approach with compose is not good. What you need, if you want to do it, is you need the other way around. And the other way around is that you need and then, because then you have for the type inference an easier way. So you're providing a type, then you're connecting something. So you have the output type already, you know what you can consume, and so on and so on. The only thing is you need to make a semantic equal function, because you are just reverting the order. But this is, from the syntactical point, a very easy or smooth way to combine functions, because a function can be constructed out of other generic functions. Means that you don't want to create a complex function. You want to reduce all functions in atomic, easy, generic, clean steps, and then based on these tiny steps, you're building more complex functions. This is one of the approaches. So solve every tiny step and then combine these functions. For this, you need something like compose or and then, and in Java, go over the way and then. Okay, so how to get a function instance? So if I have now this function +2, +10, +5, what's the right place to declare, and how to get this one? So what I can do is you can write in interfaces the static methods, and the return type is an instance of a function. And then you can declare this one in a way that it's not given with a state. This is why I like these interfaces to play there, the creation of functions of the way to create this one. And then what you can do is just, you can use function A and then the call of creating this instance of the function. So this is the first thing, to extract these generic functions to places that you can use it everywhere. And with static imports is a very short way to consume this without declaring it everywhere where you need it. So this is one thing why I like this approach, going over this interfaces, to use this one as a place for the factories of function interfaces. Wow, what a long sentence. So back to this topic, make it more generic. So function is pushing abstraction to the limits. So if I see that I have these different functions, +2, +10, +5, what I need is something, I can't extract this constants, but this is the only difference between all these declarations. So the next step would be, okay, how can I describe this more generic? So now I'm not writing down, I need a function +2, I need a function +10. Now I describe what I need. I need something that is able to create a function based on a constant input value. And now what we have, a function, and the output is a function. So value in and a function out. And then I can start building all my special functions I need, all the variations. So don't write them down, create them in a generic way. Then you're on a good way to the functional world. So if we have this one, we have now this adder instead of add5, f2, or whatever. And then I can use it everywhere with, I have this adder now applying with a constant. This is a quite compact code already, and it's a very clean code. So I don't have to maintain all the variations, because I'm declaring it once, then I'm using it explicitly in the context I want to have, and it's stateless. So that's a good thing. Okay, next one. If you're coming from the object-oriented world, mostly you are dealing with some kind of how to extract things. If you want to go to the functional world, extracting is different. For example, I'm taking this piece of code and the next piece of code. And what the only difference is this input and the other input. So now I want to get rid of this one, how to extract. If you're going over the object-oriented world, mostly you start with extract method, extract whatever, and this is leading to suboptimal solutions because the functional way is not going this way. So the first thing is you can extract this print line. Okay, now you have a consumer, you can use it a few times. That's okay, this is working. But the next thing, if you want to extract this constant because you want to have this predicate, then you have the challenge that this predicate needs a final input. So this is not working. So the extraction with extract method is just not working here. So what can you do? If you think in a function world is describe what you need. What I need a predicate created on a constant input value. So again, what I need is a function. I need a function that is able to create this predicate. And then if you have this one, you are extracting way more code. So you have a function that from string is creating a predicate. And from this one, you have now just this one extraction, this stream filter, whatever, and you can apply now this stream with different invocations of your function to create a predicate. So now you're able to extract it in a way. And the only thing that's now created or used or changed from invocation to invocation is this constant. So this is a way to extract to a functional world. So this extract method is one approach, but mostly you should start thinking about how to describe what I need. That is, if you have done it, you have a lot of stuff. We have by functions, and now I'm coming to the point that pure functional world talks about you have one input value transformed to one output value. But we have by functions. We have an object-oriented world with methods with a bunch of input values. How to connect both of them? And for this, you need currying. And the good thing with currying is that you can curry in both directions. You can curry and you can uncurry. So a by function is two input values. Then it will be calculated, and then it will be an output value. And what you need, you have to invoke it step by step. So the first transformation is you have a function that will give you, based on the first input value, a function that will consume the second input value and holds the whole transformation, the initial transformation. We will see for what this is necessary or for what we can use this one. But this transformation is more or less, we're taking all this, because if I have a by function, I can think about a try function, quad function, whatever. I can start merging lexicode with a bunch of input values and transform them from a quad function to a pure function because I'm currying it in a multi-dimensional way. And this can be done in a reverse order. So you can use a method signature with multiple input values. You can curry them. You can do all your functional work. And if you want to go back to the option-oriented world, you just uncurry everything and you have, again, this what you want to have. So means you can do it in a try function and so on. Well, I'm talking about try functions. So we have functions, we have by functions, but we will see if I want to map object-oriented code with method signatures with a bunch of attributes, I need something that I can map in a way that I have some kind of function. And this is a try function, quad function, whatever function, so that you can map easily, or you have a smooth way of mapping so that with grabbing the params, you can start working functional and reverse. And with method reference, you can have very easy mapping, by the way. I will show it in a few minutes. So how to do this? Just take your by function and extend it with one dimension. I've done it in my open source project, this tiny one, for I think 6 levels or so. If you need more, just do it or do it by yourself. But do it in exactly the same way the function and the by function is done so that you have an easy replacement. And then you can curry and uncurry because this is just one more dimension to do this. So next thing is the function world is talking about if you're invoking a method or a function 2 times with the same input value, you will get exactly the same output value. If you want to have this behavior, if you're dealing with ints, this is easy. So you're invoking a method, you will get 2 times an int, both times a 5, that's okay. But if you're creating a car or whatever, then you will get exactly the same the instance like the other one, but it's not the same identity. So how to do this one? If you want to implement the functionality of memoizing, what you need is just a concurrent hash map. And then with every invocation of the function, you will check if you calculated this value once. And if this is available, you're just grabbing it and deliver this one again instead of calculating it again. So this is just using the compute if absence. How to combine it now with functions. If I have now a by function, and I want to use this one, for example, to give this by function the functionality of memoizing, the possibility to remember what you calculated once. Then the first thing is you have to query it because the memoizing is working for one input value and one output value. This challenge we solved. We solved already with querying the possibility to have a multi-dimensional function and reducing it to a one-dimensional function. So with one input to one output. If I have this one, I can start using querying because on every level, during the time I'm querying, I have the possibility to transform this one to a memoized function. So what I have is the possibility to have a multi-dimensional caching, but I can do it just for the dimensions I want to have. Even this is possible. There's a quite interesting approach for some approaches if you want to deal with legacy code and so. But the main thing is, if you're dealing with a functional world, solve it for a one-dimensional challenge, make it generic, and then build a multi-dimensional solution out of it. And this is a quite powerful approach. So here's just this memoizing. So you're putting in a by function, and what you're doing is just you are creating or you're querying this one on every level of querying. You're just memoizing on this level, and then you're moving back to the by function and providing back a by function. So this is how to combine querying and memoizing, for example. And this can be done in a lot of dimensions, whatever you want, because for try function, it's exactly the same for quad function and so on and so on. And you can do it with functions and you can do it with by functions and so on. So there is no limitation. And yeah, that's it. So I have this one with the try function. Okay, there's a lot of code. I will present the slide so you can have this one to read it step by step. But you can see here in the middle of this memoize function that you have X, Y, Z, and you're doing exactly just for one more dimension. And this is a really nice thing with the functional approaches. If you have solved it for one dimension, you can build multi-dimensional solutions out of it. There's one cool thing what you can do with method references. It's a good and bad in the same way, but let's assume you have a legacy class, and this legacy class will have this method. You have this method do work A, 2 input values and 1 output value. And you want to do some new stuff. You have a fancy functional library or whatever, but this is consuming by functions or whatever. And how to map this? And quite easy way is if you have this instance of your legacy class, this object-oriented class, then you can extract from this instance, for example, the method reference that is bound to this instance and method. And what you see here, you don't need a cast or whatever. You have 2 input values, 1 output value, and you can immediately use here at this point a by function because 2 input values and 1 output value. This is why you should use try functions, quad functions, and all this stuff, because then you can go over this way from the legacy code immediately into the functional world. From the functional world, you can do all your stuff, and then you're going back. And for this, you don't have to change code, and you don't have to change bytecode or whatever from the legacy code. You're not even touching it. So this is one way what is quite cool if you want to combine different things here. So this is a short version, legacy class, extracting method reference, and then adding, for example, memoizing, partially caching for this instance of a method. Okay, next thing in the functional world is how to deal with branches. So we have in Java the switch, we have IfThenelse, we have this other construction with this asking sign. So we have different things, and the most thing here is that this is a complex thing. You all saw this if then else and whatever. And if you're thinking a little bit about this, how to extract it, whatever complex tree you have, you can reduce this complex tree to a linear list of decisions with a corresponding solution or calculation. And this is what I'm doing here with the case. The case is based on two values. It's a pair with two values. It's a supplier of Boolean. So yes or no. I'm responsible, yes or no. And then a supplier for the result. So what must be done at this part? So, and if you have this one, you can define this match cases. So you have a case, it's a condition and a value, and you have one default case that's just always true if no other decision before was taken. How it looks like in code is, or how to implement it, you're providing all this pairs, and then you're just iterating or streaming over this pairs, filtering out the first one that says, oh, I'm responsible, and then you're executing this one. If nothing happening here, then you're just doing it with the default solution. How it looks like in code is, instead of a complex if-then-else tree, we have now a linear list of these match cases. And the first param is how to decide if you are now this one that must calculate or do something. And the second part is just calculate the result and provide it. That's it. And now you have a very easy linear list. And the transformation from whatever if-then-else to this linear list is mostly something that is way better maintainable. And if you're using static imports, here it's a result. So it's again a map one, and then you can start dealing with cases or with mapping, transformation, all this stuff. If you're using static imports, it's a quite compact syntax. And this is something that is pattern matching just with core Java, and you can use it with Core JDK 8. No? Okay, so next one will be streams. The same with stream is streams are active after creation, and you want to define streams, but you don't want to start them. And you can use a functional approach with this because you want to interactively create a stream. And if you have all parts together, then you want to invoke it. What you have is you have a function that is building based on input values, the definition of a stream. And if you're applying this function, the stream will be created and allocating resources. And with this one, you can really, if you have a graphical user interface, for example, you can collect different informations. You can partially build with and then the final stream based on functions, and then you can invoke it and work later on it. So this is just decoupling the time of definition and execution. And talking about decoupling stuff is now the part that's leading to the reactive world. The easiest thing is just an observer as a ramp up. So it's just a concurrent hash map. You have a key, you have a consumer for the value. And then you can say register, unregister, and send is just iterate over all items and invoke with this value. The only thing is, have in mind, Java is not immutable. So it means make sure that the consumers are not playing around with the value itself. So this is not safe at this part. But an observer, just to decouple these consumers from each others, or the producer and the consumer, is just a few lines of code. But there's one thing that is not nice, is you need to remember your key to unregister, because you have to provide a key. And so sometimes you don't want to have this one. So the first improvement is that you're playing around with the registry. So you're using this observer, but it will be wrapped in a way that during the register time, you will create something that you can give back to make it easy to unregister. So this is the first thing with this keys. We want to get rid of keys. And for this key, to get rid of one, you're defining an interface called registration. The only method is remove. And then during the execution or during the registration, what we are doing is just we're creating exactly this registration. And this registration is then removing itself from the map. So I think I have somewhere the code for this one. Yeah, so it's just we're registering now. And yeah, to get rid of this key is just that we are using now, instead of just adding the value, the register method will implement the registration, and the implementation of this removes this registration. It's just remove yourself. So that's it. So it's a little bit easier, it's more handsome, and you can't mess up with lost keys. And then you have the first thing. But talking about complex trees of invocations, if I'm talking about the completely future, the most thought already, I assume, is it's not a process, not a thread, it's a fiber, it's very lightweight, and we have this completion stages that I have to deal with. So what can we do, and how we can combine it in a syntactic way to reduce it, and then what we are reaching out. So with just as a recap, with completely future, take the advantage that you can define the pools where it's running. So if you're dealing with completely futures, if you have a CPU intensive pool, it's a different one than to have a network intensive pool. So dimension them wisely. Then you can just create your completely futures with completely future.supply asynchronously. What we have now is immediately this complete future is active, is running, is consuming resources. But on the other side, you see here the supplier is more or less a function. So the functional world, if you're extracting all this stateless behavior and want to go to the reactive world, then you have the halfway done. And this is a good thing. So if you want to have functional reactive, go first to the functional world, do this one right, and then start with the reactive world. It's way easier to instead of doing both at the same time. Okay, you can start combining and accepting and doing all this stuff. Don't forget to shut down this pool, otherwise sometimes the JVM is just not ending. So what I want to have, I'm looking at this syntactical stuff, and I want to make sure how to make it very compact, because I want to have a very compact way of dealing with this. And this functions itself, okay, we saw we can extract it in this function interface to create this factory methods, for instance, of functions. For every step, I can provide different executor pools. That's nice. But now, how to remove, how to build some complex stuff. For example, I have a value A, B, and C. So value A and B are coming at different times. I'm waiting. I have something that should be calculated. If this one is done, I have the value C, and this is coming at some time. Maybe it's the first, maybe it's the last. You never know. But only if A and B is calculated, then you have the input for the next operation, and this is the final result. So looking at this one, it's a quite complex tree. It's really a quite complex tree. How to do this one with threads and all this stuff is a huge amount of work. If you want to get rid of this and you're using completely futures, what we want to extract, the operations, if they are functions or stateless, then the half work is done. So how to combine now all this timing stuff here? If you're doing it with the classic completely future approach, so you're creating the first one, the second one, the third one, then you start combining them. And with every combination, you can provide the next transformation, so an instance of a function. But looking at this code, it's a lot of syntax. It's a lot of stuff. And if you start with supply asynchronously A, B, and C, you're allocating immediately resources. And you don't know how long it will take until you have this value, for example. So we want to make it a little bit more smooth. But first, working on the syntax. So we can write it a little bit more compact, because I can just make sure that I'm supplying the first one, and then I'm supplying the next one. I'm wrapping this a little bit together and making static imports and all this stuff. But even this is a lot of code for doing always the same. So I want to highlight one more thing. Sorry. I want to highlight one more thing, and this is that for every combination, you can switch pools. So for every stack, you can provide a different pool. It's not necessary, but you can do it. And with this, And with this, you can balance the utilization of your hardware, which you have at this point. But if you are just using one pool for the first example, it's fine. So playing around, I want to have this concatenation function. For example, I'm just extracting. I have now these different suppliers that I'm defining somewhere. It's functions somewhere defined. So it's somewhere this boundaries or these values are coming from. Could be a network, could be a read from file, whatever. Something, I don't know, different timing in timing behavior. Then I want to connect everything. So, and if I'm extracting this function, I see that at this part, this then combine asynchronously. And so this is a lot of code, how to get rid. So the next thing is, this operation is just this definition. So just have in mind that this complex decisions and timing stuff is just this little bit amount of code. But if we are talking about design pattern and what we learned and how to combine all this stuff, and I spoke a lot about this function stuff. If you are going functional, you are just deleting your knowledge about object-oriented. If you're in your functional world, you're not consuming your knowledge about your object-oriented world. No. Is there something that you shouldn't do? No. I think you should combine both of them. So if you're going functional inside the JVM, it's good to mix it in a level that fits to you based on your skills in object-oriented and functional programming. There's one example I want to show. For example, here the complete future is active after creation. There's something I don't want to do. If I want to start defining completely future so that I'm decoupling the way of defining what I want to do and explicitly start running, then I need something that is able to hold the definition without starting. And then you can do exactly the same with the streams. You can create a function based on an input value, creating a functional completed future. But going back to this example, what I spoke about is if you have different functions, whatever functions, where they are coming from, and I want to combine them in this tree of execution, I have to write a lot of stuff. What can I do to extract this boilerplate code? What can I do at this part? Because I have this compose async, this supply async, and all this stuff, I want to get rid of this stuff. I want to have something that's compact. For example, this one. And I want to decouple the point of defining what I need and allocating resources and executing. So for the first one, for the second one, so defining and then executing, I know I need a function because then I can declare everything and then I can invoke. That's one approach. On the other side, I want to get rid of this completely future synthetic stuff because I just want to have these functions and then I want to define and combine, for example. If you're from an object-oriented world, you know the pattern builder, the builder pattern, and why not using it? So if you now start combining both of them, you can get rid of this syntactical stuff, even with object-oriented design pattern, but it doesn't mean that you're giving up your functional approach. And here, this code, it's a lot of code, but it's more or less just a builder pattern. You're defining stuff, you're adding attributes, you're doing some stuff, and if you have everything together, you're giving something back. Here, you're giving back a function that will create it just in the moment you need it. But on the other side, you have a builder pattern. So my advice here at this point is start with a functional approach, do it with Core Java, then start with a reactive approach, but don't forget the object-oriented stuff you learned and combine it to the tools you need and you want to have. And then you have a very powerful tool set with even the Core JDK and without adding any library, because this is just, if you see the implementation on GitHub, it's just a few lines of code, really, not so much. And you have a complete new paradigm. So this is, I think, the window is closed. I'm back here. So this is what I wanted to explain with the functional reactive, with its functional approach. And yeah, if you want to know more about, connect via Twitter, ping me via LinkedIn, whatever. Have a look at my YouTube channel. Since COVID, I'm not traveling, so I'm going to the forest and doing there my talks for recordings. Otherwise, I hope you enjoyed it. And yeah, give me comments, try it out. and happy coding. And so.
Thank you, Sven. That was a great, great walkthrough, and I have to say I was noting a lot of stuff that I am definitely gonna follow up. A lot of interesting stuff on the functional programming part. And I just made some notes that I just wanted to ask you. What do you think about the future of Java in terms of you know, the evolution of the language and towards functional programming, and because the type signatures of Java can sometimes make it, you know, a little bit difficult to get the overview of the whole, or the readability and so on. Do you have any thoughts about this stuff?
So first of all, what I really like with Java is that you're not pushed to one direction. So you can code it object-oriented, you can code it procedural if you want, you can code it functional. So this is one thing I really like. There's one thing that is maybe not powerful enough for a lot of functional stuff, is this typing system with generics and all this stuff. On the other side, I don't want to have it like Scala, so that my compiler is just going mad over the time and taking hundreds of years until the compile is done. No? So I think the balance between the type, how strong or how flexible the typing is, and the different approaches and syntactical stuff is what I like, and I really like it. Maybe it would be nice if you have some kind of immutability if I want, but not per default and push through, so that I can decide if I want to have something mutable or immutable. So this is something. But I think in general, I think the community will lead the development of the roadmap of Java, and we will see what the most of us will need and use for the Java world, and then it's just fine. So it will go the way of the community. That's good. Oh, you're on mute.
Yeah, thanks. Gertjan, I just wanted to ask you a question about Foojay for the viewers and people who join us later on in the stream. What was the motivation behind creating Foojay, and how can people use it how can they get the most out of it?
Well, the motivation behind it is that we don't have a community site so far as Java developers. I mean, in Sun Microsystems times, there was one company that was doing Java, and now there are multiple companies doing Java. You know, Amazon, Red Hat, Azul, Liberica, Bellsoft. You know, there are so many companies doing Java that there isn't one site that connects all those different stories together. I mean, where would you go if you are a new Java developer? So ultimately, what we want is for Foojay to be the place that if somebody says, hey, how should I get started with Java? That the answer is Foojay. And if somebody says, you know, what are some tips, what's the best place for tips and tricks around Java? That the answer is Foojay, because it's a place for friends of OpenJDK. So that kind of site, other technologies have, Python, Ruby, you know, languages, because the organization backing it it's much clearer who is behind a particular technology. It's much more coherent. So that's why we've created this, because there's clearly a vacuum for such a meta level Java site. And now it's here. So to get involved in it is you follow on Twitter and you join the Slack channel and you say, hey, I have content to share, or I have tips, or why don't we do this, or why don't we do that on Foojay, or this could be better. We can make it happen together. It's all very community driven. That's the whole point.
Yeah, very nice to hear. May I just ask, I have been curious about wanting the name Foojay.
Yes.
Is there any story behind this name?
Yes. So when you see the subtitle, a place for friends of OpenJDK.
Aha.
So Foojay has in it the F for friends, and the O of and the O for open, because the problem with a Java site is you can't use the word Java, because the word Java belongs to Oracle, right? So if you come across any site that has Java in the URL or in the name, there's going to be legal issues with Oracle at some point, because Oracle owns that name. So we have to hide Java somehow in our name. So Foojay means friends of OpenJDK.
I have been clicking and looking around Foojay, and I have to say that I immediately when I looked through the bug fixes and the changes in the language, just clicking into, for example, JDK 16 and going onwards, I immediately felt much more informed about all those tiny, changes and
Exactly. Yeah, exactly.
And it definitely made well, I felt more connected, because now I can actually have a quicker way of accessing those lists. So I have to just congratulate you with Foojay, and I really look forward to spread the word, and so it can be useful for many developers. I have, of course, since the new release cycle of Java, I saw different matrices from different people making, trying to visualize all the distros and changes and so on. So having them on one place has been very, very cool. And I have to say thank you again. It was very, very cool to have you with us and to share. This meetup is recorded and will be available on our YouTube channel. Sven, yet another great talk. I remember you joined us in last year as well, and your talk from last year is also available in our YouTube channel. And yeah, I hope everyone had a good evening with us. And I want to say thanks to my fellow javaBin heroes that helps us with organizing our meetups. And Gertjan, thank you. Sven, thank you so much. And with that, I will say thank you for watching, everyone, and have a good evening.
Thank you very much.
Bye.